process of construction was quite tedious and had a lot of places where it could go wrong. We first assembled the straws and cut them to length we would need. We had to make sure the gaps were fully sealed, otherwise either water or air could leak into a container and it was not supposed to be in there. After that, we had to drill all the holes we need in the caps and the bottles to prepare to put it all together. The whole straws are then threaded through the holes in the caps and the small bottles are attached to the top. All the straws are glued in place and the bottles are screwed into their caps. This is another vital step because if there are any gaps in the glue, water and air will also be able to flow between the tanks and that will decrease the pressure difference. After completing our construction, we went and tested the device. We then found that it did not work, so we had to deconstruct it and rebuild it better. This second time, we were able to get a small bubbling fountain.
So, experimentally talking, the engine is started by pouring a small amount of water into tank A, which will increase the weight and therefore force more water into tank C, increasing its height. C, increasing will displace the air into tank B, which in turn forces water out of B up into A. This water is what appears as the fountain. With more water now introduced to A, the process will repeat and sustain itself until A and Z balance out or B runs out of water. It depends how well your system is constructed. The air leaking and will increase the pressure that C can exert on B.
First, you define your pressure equations. This is the height of and density of the water and the air for the air bubble trapped in the system. Then you take your Bernoulli equation I hope I have enough space for this. Alright, just barely. Then you see what cancels. The velocity is going to be the same. There's no pump in system. So you end up with pressure 1, density, height equals to you might notice I forgot Z2. That's fine, just bring it back, everything's fine. But there's your
Looking at the data, it was very clear while running it that it was not running fully, and we could see both air bubbling out of tank B and water going back into fill its place, but it did complete the task that it needed to, so this will mean that the pressure being produced by C was not actually transferring back up to A effectively at all.
The loss in pressure could be witnessed in two ways.
One, of course, was the height of the fountain spout, which decreased over time, and the other was the fact that the system fell into equilibrium before container B was emptied. The small spout was caused by the general friction forces, head loss, and air's compressibility, and on top of that, there were leaks present in the system, which is what led to it actually falling into equilibrium well before the estimated runtime.